Could you provide us with state-of-the-art database model designs? Oh, okay, that's a big ask. Things like a CRM database model, a bookshelf, an eBay kind of application.
Okay. It sounds to me like the person asking the question is kind of looking for sample models, sample applications, and I hear kind of the question behind the question, which is, how do I go about modeling an e-commerce site, a CRM site, in this non-relational NoSQL world? Right. I want to build an application that can handle tremendous scale, but you've kind of swapped the tools out for me. I'm used to doing development on a SQL database, relational. I know how that works, but I know that that doesn't scale. So help me switch. Right. I think it's difficult to come up with samples that fit every single vertical, but there are some general things that we can say about the way you do data modeling, and really it's sort of kind of changing some of your habits and some of the things that you were taught maybe from the beginning working with relational databases. So one of the kind of the first tenets when you're building a relational database model is everything needs to be normalized. No data duplicated. It's typical in an order entry system to have 5, 6, 7, 10, 12 different tables that every time you want to do a query and find out what the orders are, you have to join all these tables at runtime and select your results. So you might have a table that has items in it, and it has item description, item price, and some other information. Then you have an order lines, which connects to an order header. You have order line details. It goes on and on. And this is a really good way of allowing you at runtime the flexibility to really join any amount of data with any other amount of data, which is what relational databases were built for. But in a very scalable world, what you want is actually that if you and I both make a request to our website and we're both interacting with the service, what we want is for your queries and my queries to essentially be able to be handled by different parts of the infrastructure. So it's a distributed platform. And the way to do that is to sort of isolate your data from my data. And that means what we don't want is for, if I'm pulling up a list of my orders and you're pulling up a list of your orders, we don't want to both be going to the same table and kind of running into each other. We also don't want to take a lot of time at runtime kind of collecting the data. We, in distributed systems, what you like to do is kind of amortize the costs, spread out the costs, and do the costs at write time. So when we write the data, we might do some deduplication. So what you would call denormalization. So it's quite common in App Engine apps for entities to have properties with string values. So rather than have an item key on your item details page, you would actually have like the actual item code or the actual description. If you're putting together, let's say, countries, you have a kind that stores addresses and you need countries. In App Engine, you would actually just put the country code or even the full country name in every single entity. And you should kind of resist that urge to say, oh, I don't want the duplication of data. I don't want to pay for the extra storage. What you're really doing is you're separating your data and my data and making it very efficient to handle very large number of requests. There's kind of more best practices, but the first one that you kind of want to think about is denormalization is not a bad thing. Yeah. It's actually something you should really just embrace and think about. Just pick 2 users and imagine that they're both doing kind of the same thing in your application. How can you make it so that the entities that you're touching and the entities that I'm touching are different? Because as soon as they're separated from each other, then the Google App Engine infrastructure, the data store, can put those entities on different physical hardware, different machines, and now we can add a 3rd user, a 4th user, a 5th user. We can have 100,000 users. It really doesn't matter how big we scale up because each user is accessing a different part of the system. Wow. So there's kind of a lot to grasp if you're coming from a SQL environment, but once you play around with it for a little while, it's really freeing to say, I really don't care how many users show up on my doorstep tomorrow. I can handle 1,000 users, 1,000,000 users, 1,000,000,000 users. It's really independent of scale. And that's what the App Engine Data Store provides, is performance that's independent of the amount of data that's stored.
Yeah. Excellent. Oh, that's really good advice. So, okay.
All right, so Sorry for the long answer there.
No, I think it's the kind of question that deserves a long answer.
Yeah, it's a common question, so it's fair to spend a little bit of time.
A lot of people moving from the traditional relational database world to the NoSQL type world.
Yeah. Oh, and we should say if you do want a relational system, you have a limited number of users. You're building a corporate application. You only know you'll need the existing performance. You can use Google Cloud SQL. Yeah. It's a MySQL database, runs in the cloud, managed for you, no headaches, and you get all the traditional kind of performance trade-offs and benefits. So that's still an option.
Yep.